All right, we're going to talk about Coulomb's law now, okay, and it's just this one section right here, so super, super brief, okay. Coulomb's law is something that we learned, again in Unit 2. This is simply the force, the electric force is equal to KQQ over R squared, okay. Or if you really wanted to, you could do that the electric force is equal to 1 over 4 pi epsilon naught times Q over R squared. If you really wanted to do that form, you could. K is the Coulomb law constant. Coulomb constant, and that's equal to K equals either 9 times 10 to the 9 or 1 over 4 pi epsilon naught. Okay, those are both on the formula sheet, so you don't need to memorize that. Okay, epsilon naught is a constant. This is the vacuum permittivity. Okay, permittivity of free space. That is not permeability of free space. That's different. That's used for magnetism. Okay, and epsilon naught is equal to 8.85 times 10 to the negative 12 coulombs squared over newtons times meters squared. Okay. And you don't really need to know that if you know the Coulomb constant. You're not really going to have to use the permittivity of free space if you know the Coulomb constant. Okay, by the way, I forgot to mention the units for this one. It's newtons times meters squared over coulombs squared. Okay, I guess if you think about it, right? 4 pi doesn't have any units, and has the units of Coulomb squared over newtons meter squared. So then when you flip it, because it's in the denominator, when you flip it, it would just be that, right? Couple of other things to know is that little q and big Q are the charges acting on one another. Okay. And R is the distance between charges. Okay. Okay. That's it for Coulomb's law.